Hello students, in this video we are going to look at testing hypothesis with one sample test. So hypothesis testing begins with an assumption called hypothesis that we make about a population parameter. Then we collect sample data, produce sample statistics and use this information to decide how likely it is that our hypothesized population parameter is correct. We cannot accept or reject a hypothesis about a population parameter simply by intuition. Instead, we need to learn how to decide objectively on the basis of sample information, whether to accept or reject a hunch. So, just to understand in more depth, let us look at this example. Right? For example, uh, suppose we want to test a hypothesis that a population mean is equal to 500. So we should symbolically follow it and read it as null hypothesis that population mean is equal to 500, and we will indicate it as H naught, null hypothesis, mu equal to 500. So why it is called as null? Because null means there is no difference between the hypothesized mean and the statement what he is making, and actually we are sample is indicating. So there is no difference. That is null hypothesis. Then the hypothesized mean is called as mu h0. Mu h0. So the hypothesized value of the population mean is indicated by mu h0. Now suppose we take example whenever we reject a hypothesis. So when we have this null hypothesis, when we reject a hypothesis, the conclusion we do accept is called as alternate hypothesis. So along with null hypothesis there is an alternate hypothesis, but then there can be different alternate hypothesis. So to understand that, let us write it like this. Let H naught, the null hypothesis, be mu equal to say 200. Then we can have three possible alternate hypotheses. First, mu not equal to 200. That means the mean which sample indicates is not equal to 200. Or H1, the mu is greater than 200. So the alternate hypothesis is that the population mean is greater than 200. Or alternate hypothesis can be mu less than 200. Right? So that means population mean is less than 200. Now whenever we are saying this, there is a significance level attached to it. So the purpose of hypothesis testing is not to question the computed value of sample statistics, but to make a judgment about the difference between sample statistics and hypothesized population parameter. So if there is a significant difference, then we will reject the hypothesis. If there is no significant difference between what sample is indicating and the hypothesized mean, then we accept the hypothesis that the population mean is so and so. So that is why the significance come into picture, and there has to be a significance level which we must declare before we start hypothesis testing. Right? Now there are two errors attached with this hypothesis testing, that is type 1 error and type 2 error. So what exactly is type 1 error? Rejecting a null hypothesis when it is true is called type 1 error, and its probability, which as we have seen is also the significance level of the test, is hypothesized alpha. So alpha indicates the probability of type 1 error. Type 2 error is accepting a null hypothesis which is false, and it is called as type 2 error, and it is the probability is symbolized by beta. Right? Let us understand the meaning of 5% significance level just to get into more details. And acceptance and rejections area. So when we say 5% significance level, then we are actually indirectly saying that it is 95% confidence level, because 1 minus confidence level is significance level. So if you look at this diagram, the between these two limits is your acceptance area, which is 95% of the area, and on the right side and on the left side your rejection area is there, because this is 5% significance is divided into two parts, 0.025 or 2.5% on the right side and 2.5% on the left side. Right? So if we if our sample indicates in sample mean is falling in the rejection area, or either on this side or this side, then definitely we are going to reject the null hypothesis. So let us understand this in again more depth by taking some example. Right? For example, the first one is one tail and two tail hypothesis testing. The first one diagram indicates two tails. Why? Because your rejection is on the left side as well as on the right side. And then two tail is written like this: mu equal to 200 is your H naught, null hypothesis, and mu not equal to 200 is your alternate hypothesis, and significance level is 5%. So 0.025, 0.025, or 2.5%, 2.5%. And the middle one is 95%. So this is your two tails, because there are two rejection tails. Suppose the alternate hypothesis is that the mu is greater than 200. So null hypothesis remains as alternate hypothesis is greater than 200, and again alpha is 5%. Then it will be shown like this: if our sample parameter falls in this particular area, in fact we will be using Z, two types of Z, Z calculated and Z table. We will come to that bit later. So if it is falling in this area, then we say that there is a significant difference between this hypothesized mean of 200 and the what sample is indicating. Right? So this is, so we reject the null hypothesis, because this is our rejection area, and this is our rejection area, and this is our acceptance area. So because we are in this region, then we reject the null hypothesis and we say that the mean is greater than 200. Suppose the mean is our assumption is that our hypothesis is that the mean has dropped and it is less than 200. Then our rejection area will be on the left side, and we will say that this left side is your rejection area, 5%. Right? So if it falls here, then we will say that, then we will conclude that there is a significant difference, and hence we reject the null hypothesis that mu is 200. Actually we conclude that mu is less than 200, it is falling in this area. So this is how we state and test the hypothesis, null and alternate hypothesis. In my next video, we are going to now look at the examples based on what we have just now seen. Thank you.